Hello guys, in this video I wanted to explain how the volume data is present in Houdini and where it is located, and what context can we use it with, and how to work with the data. So we have two different types. We have either a smoke sim, where we take any object or any source and we create a smoke sim out of that, let's say an explosion or a dust hit or a car trail, a car dust trail, anything. And then we have the static clouds, the static procedural cloud, the static procedural volume, let's say cloud, or you have noisy atmospheric effects that you want to create, or you have some kind of fog at the ground level that you want to create, for example. And all these are static procedural volumes. They don't interact with the sim. And we looked at geometry data in Houdini, and we saw that everything is located under the OBJ context, and this is SOPs, everything we created in SOPs. So we have geometry, we looked at points as well, and the same way this data is available, we also have access to volumes. And we can create volumes. We can take any object and convert it into a volume. We can also generate volume from nothing. Just take a container, fill it with volume data, and use that. We can, for example, copy multiple spheres, fill them with volume, and then add some noise to them to create a cloud. And this volume is, again, a static volume. It doesn't have anything related to the sim. We can do all this processing in SOPs. Then we have the sim part, and this is where the DOPs come in. So with the DOPs, like we did with the particles, we prepare the input or the incoming in SOPs. We pass it to the POP solver or the particle solver, or a DOPs with particle solver, and then we take the data back. So in the case of Smoke Sim, we take any object and we prepare the volume data in SOPs. Then we pass this to DOPs, where we can use either the pyro solver, the smoke solver, or create anything of our own. So we have smoke solver, pyro solver, and these are the things that we can use to interact with the volume data. It does the sim, and then we import back the data that we need, in this case the volume data. Now inside here, the DOP solver can decide to change that data or add new elements to it or expand it, but we only need what is visible for us. We only need what we call a density field from the solver. Now, like we do with attributes, with points, we have attributes on them. So we have points and primitives, and these we can add attributes. For example, with point we have P, N, we have ID, we have color, things like that. With primitives we can create anything as well. We have primnum, which is the primitive number, and we can create, for example, a cluster or a class, any attribute we want. With volumes, these attributes, they are not called volumes, they are called fields. And the key one that we work with most of the time is called density. So with volumes, we have density field. If the smoke is moving, for example, or is coming out of the sim, we will get another information for motion blur, for the velocity, and that field is called vel field. Okay. Now, like with this, with these attributes, we have P, which is a vector, N, which is a vector. This ID is an integer, and we can create other things as float as well. Float my attribute, for example. Same thing with the density, with the volume. We also have a scalar field, which is a float field, but we use the term scalar, which is equal to float. And we have a vector field, which is, in this case, a velocity. We can have, for example, a color field in the volume. We can have as a vector, color field as a vector field. We can add temperature, for example, temperature field, and this is a scalar field. So we have two types, either a scalar, a float, and or a vector. Okay. Now with volumes, like with a surface, for example, we have a polygonal surface and we have a NURBS surface. Okay. Each one has its advantage. Each one works differently. Now, what side effects has, or at the beginning, they have their own volume data, and that is the Houdini native volume. It doesn't have any specific name to it or a keyword. It's just called volume, and that's how we work with volumes in Houdini. After 2014, they integrated something called VDB, and that's the second option to interact with volume and use and create volumes, manipulate the data and things like that. Now, when we are in SOPs, we can use either VDB volumes, and this is a plugin developed or a framework developed by DreamWorks, and they were kind enough to open source it, so a lot of software has adopted it, and it's very memory efficient, and it can handle a lot more data much faster than the Houdini native volume, and we're going to see that as well. So in SOPs we have either VDB volume or Houdini native volumes. Okay. One key difference between these two, this is a little bit advanced, but I want to cover it. With the native volume, what side effects does to describe a color field or a vector field, it creates three different scalar fields, three separate scalar fields. Okay, three scalar fields, and they are called val.x, for example, val.y, and val.z, and you will see them like they're exactly the same as a density field. The native Houdini volume does not have a field type vector. It fakes the volume or the vector field by creating three different scalar fields. Now this is not so important, but I think it's worth mentioning at this point. With the VDB, they have a scalar field type, and they have a proper vector type. So we can create a velocity, and you will see just one field in there. Okay, so with this, we're going to be primarily focusing on the VDB volumes because it's much more efficient with in SOPs, and we have a lot more tool set to interact with it. Now, when we work from SOPs, we pass data to DOPs. Okay, let's say, for example, we take a sphere and create a density field from that. We pass this sphere density field to DOPs. It's going to create new smoke. It's going to emit density from it, and we can add wind, we can add turbulence, and then what we extract from it is another density field. Okay, from DOPs we import only the density field. We also have access to any other fields that the DOP solver created. There is a variety of them. They're not all useful for us to extract. We only import the density field, temperature field, and the velocity field. Cool. So with this, we also have ways to work with the volume data. So while we are in SOPs context, we're going to use we're going to create volumes, VDB volumes, and to process these guys, like we use with the point VOB, we use an attribute wrangle or a point VOB to process the point data. With volume, we use simply a volume VOB. It's called volume VOB, and there is a similar one to it that is called volume wrangle or wrangle volume or something like that. And these two are the same. You can either write VEX code directly, or you can use the graph to process it. Okay, so let's take a look at this in action and see how we can convert this geometry into an interesting volume. Thanks for watching, and see you in the next video. Bye bye.